In this video, I'm gonna tell you everything you need to know about diffraction in macro photography. And I'm gonna try to explain this very simply using simple, intuitive examples so that you can grasp this without knowing any theoretical physics and stuff like that. At least not too much. And diffraction is a tricky subject which few people really understand, and it gets even trickier in macro photography. But let's start with diffraction in regular photography. And to understand this, we first need to understand aperture. So if we take a regular lens, this is the Samyang 135mm f2. We have a scale here with different apertures that you can set. Goes from f2 to f22, and as you might know, f22 is a very small aperture. It means it's a small opening through which light can travel into the camera. And then f16 is slightly bigger, f11 is even bigger, and f2 is very big. Okay, so that's aperture. But what is diffraction? Well, the simplest way to put it is that it's a physical phenomena that makes your photos slightly blurrier. And in some cases it can be a real problem, especially in macro photography. And in this video I'm gonna explain exactly why your photos get blurrier and why diffraction is an even bigger problem in macro photography. You might have heard that you shouldn't use smaller apertures than f11 when shooting landscape, for example, because you will get diffraction, you will get a slightly blurrier photo. So what is diffraction and why does it happen? I'm gonna attempt to explain this now using some drawings on my iPad. And when we understand diffraction for landscape photography, we can then start talking about diffraction in macro photography. To understand this, we will first look at water and water waves, because the thing is that light behaves as waves, and when it comes to diffraction, it behaves exactly like water waves. So imagine that we're looking at the ocean from above here, and someone has built a barrier here, which is red, with an opening in the middle, a pretty wide opening. And then the waves from the sea is coming here. Waves are approaching, and they pass through the hole. No problem, nothing strange. But what happens if we make the opening smaller? A small aperture. Say that it is very small. Well, the waves come here again. But what will happen now is this. The waves will disperse a bit. And actually, light works exactly the same. When light passes through a small aperture, like the small aperture in your lens, it will disperse a bit. However, I like to view light more like lines, like light rays traveling. So let's try to put up a sensor here. This is a camera sensor, and this is the aperture in the lens. And then an image consists of lots and lots of light rays. That's an easy way of thinking about it. So one ray comes from here, maybe. Maybe I'm photographing a flower. Another light ray maybe comes here and hits the camera sensor here. And the light ray here from the middle comes here and hits the sensor here. The thing though is that when we have a very small aperture, each wave will be a little bit dispersed. So this one, for example, will hit even here and a little bit here, and each of these waves will hit a little bit to the side. And this is what creates the blurry image when we have a small aperture. This is the diffraction. Each light ray that should only hit a specific spot on the sensor actually hits a little bit on the sides, and that creates a blurry image. For example, if we would have had a wider aperture in the camera lens, then we will not have this problem. Then each light ray will just hit exactly the same, the spot on the sensor where it should hit, and everything works as intended. So why does light behave like this when it passes through a small opening? Well, actually, I'm not sure. I tried to find an explanation for this, but I didn't see one when I did research for this video. Maybe nobody knows. I'm not sure. If you know, comment below. Anyways, that is diffraction in the general sense. Diffraction when you're doing, for example, landscape photography. So let's talk about diffraction in macro photography and why it is a big issue. Let's look at this lens again. We see the different aperture markings here. And what not a lot of people know is that these markings, f2 to f22, they are actually only valid at infinity focus. So if I focus any closer than infinity, the effective aperture, the real aperture or the numerical aperture will actually be a lot smaller. If I take a portrait of someone a few meters away at f2, the real aperture is probably like f2.8 or something, or at least above 2. And if I set a macro lens at f2.8 and shoot something at 1:1 magnification, the real aperture, the effective aperture, will then be f5.6. And if you're shooting something at 2 times magnification, the real aperture will be even smaller. And actually, the higher the magnification, the smaller the effective aperture will be. There is actually a table for this. This table I got from the instruction manual for the Canon MPE65. So look at these numbers here. At 2 times magnification, when the lens is set to f8, we actually have f24 in effective aperture. And at 5 times magnification at f8, we actually have f48. So why does the aperture become so much smaller? I mean, we didn't change anything with the lens, right? We only focused closer. Well, this is a bit tricky to understand, and my own intuitive way of understanding this is the following. 2 things happen when we have a smaller aperture. First of all, we get less light, right? It gets darker. If you stop down a lens to f22, you will have to have a lot of lighting on your subject to get a good photo. The other thing that happens, as we have talked about, is diffraction. The higher the f number, the smaller the aperture, the more diffraction we get. So why does the f number increase so much when we focus closely? Well, if we first look at the light, I try to imagine that as when we have a high magnification, what we're actually doing is we enlarge the picture a lot and we only look at a small cropped in part of it in the middle. That is what happens when you have magnification. You enlarge the image, you only look at a small part of it. And a photographic image consists of a lot of small light particles. Light can behave both as a wave and as particles, or actually it does behave as both at the same time. That is how physicists look at it. And an image is actually just a lot of photons, light particles that have been captured on the sensor. And if we only crop out a small part of a picture, we will have less light particles, right? And that is why when you enlarge an image, it gets darker. And the more you enlarge it, the darker it gets. So that would explain the light part of why you get a very small effective aperture when we focus closely. That is why it gets dark. But why do we get more diffraction? Well, the way I like to understand this is that if we have an image which has some diffraction, some softness. For example, let us look at this image I constructed here. This is just white on the left, dark on the right. And it's sharp. Let's add some diffraction softening. I just do a blur here. Okay, it's slightly unsharp. Maybe we shot this at 1 time magnification. What if we double the magnification to 2 times? That would mean I double the size of this image and I crop in. That is what happens in the camera as we focus closer with a macro lens. Do you see what happens with the blur? Yes, it gets blurrier. And this is at least my intuitive way of understanding why we get more diffraction the higher magnification we have. So what does this all mean in practical terms? How do we use this knowledge to get better macro photos? We need to have as small aperture as possible in macro photography to get any kind of depth of field. As you know, the depth of field becomes very, very thin when we focus closely. So we can live with a little bit of diffraction, I think. It's worth it to have a good depth of field. So what I try to live with is around f22 worth of diffraction. And then we can look in the table here that we looked at earlier in the manual for the Canon MP65 lens. And then we can see that, for example, at 2 times magnification, if we can live with a diffraction corresponding to f22, well, then we can shoot at roughly f7 to f8 at 2 times magnification. And we can shoot at around f11 at 1 time magnification. And that is exactly what I tend to do. I put my limit there. I get a slight bit of diffraction softness, but it's almost not noticeable. It's just a small touch of diffraction. And you have to, for yourself, decide where you want to be in this table. Maybe you want even deeper depth of field, and maybe you can live with more diffraction. Well, then maybe at 2 times magnification you can go as small as f13 in aperture on the lens, which means an effective aperture of f39. But that will give you quite a lot of diffraction. But if you're only gonna post a photo on Instagram, maybe you will also apply some sharpening in Lightroom, maybe that can be acceptable. It's up to you to decide, but a table like this helps a lot. An important thing to think about here as well is that the higher pixel pitch you have on your camera, the higher amount of pixels per inch or per centimeter you have, the more you will notice the same diffraction. So say that you have a Sony a7R4, I think that camera has like 60 megapixels or something. That is a very high pixel density, and then you will start to see the diffraction sooner because you have so many pixels. So this is why I don't think that sensor resolution is that important in macro photography, because you will be limited by the diffraction anyway, and the diffraction will come with magnification and there is no way around it. It is laws of physics and we can't really break them, can we? This was my attempt to explain diffraction in macro photography as simply as possible. I hope you learned something, and please give me a like on this video if you learned something and if you liked it. See you very soon again in another video about macro photography. Bye bye. This is my latest Patreon bonus video. It is 1 hour of me critiquing many photos of my Patreon supporters. Another bonus video is this macro photography adventure to a nature reserve. I create a new Patreon exclusive bonus video every month, and for $5 per month you can get access to this growing archive of videos and sleep better at night knowing that you ensure the future of this YouTube channel. Sign up now at patreon.com/Micael Widell.